Today we're going to be learning about partial fraction decomposition. In this lesson, we're going to be observing the procedure on how to decompose a rational function into much simpler functions, meaning we're going to break down fractions with polynomials in order to find smaller, simpler parts. Let me try to illustrate this more effectively. We already know from algebra how to go from this equation to this much simpler one, to finally adding them up. What we're more interested in now is using the final equation and going the opposite direction to find the original one that we started with. Well, why is this so important to calculus? In several integral problems that you might face, it's going to be much easier utilizing this procedure. The partial fractions are going to be much simpler than the complicated fractions you will originally see. As seen in this integral problem, it was solved by completing the square and using trigonometric substitution. Seems scary, huh? This is the same integral problem, but it was solved using partial fraction decomposition. Not that scary, huh? Let's look at the following partial fraction decomposition problem. Our first step is to factor the denominator. We should include one partial fraction for every factor found. Afterwards, we're going to multiply both the left and right side by the least common denominator to find what's called the basic equation. We have to find the zeros of both a and b. For each of their respective value, we plug them in separately to solve for a and b, which gives us our final answer. This is a basic example to help illustrate the most fundamental steps in such a problem. First, factor the denominator and then write a partial fraction for each factor. Then multiply it by the LCD to yield the basic equation. Finally, our last step is going to be finding the zeros of the variables and then plugging them into their respective equations to get our answer. Let's take a look at the following problem. The only noticeable difference that's imperative to notice is that there are going to be some repeating linear factors. It's important to include each power of x as a factor. The following procedure is the same as we previously discussed. The only difference is the extra work with an extra variable. We still multiply by the LCD and then find the zeros of the denominator of each variable and plug them in accordingly to get our final answer. Thank you for watching this video. Partial fraction decomposition is a relatively easy topic with linear factors that only requires following these steps. Be sure to notice any repeating linear factors as they may pop up. With that said, I hope you've enjoyed this video.
Created using Powtoon.